Okay, let us move forward and let us do a few more questions on the same concept. Only the thing is that now I will take extended complex plane also. We'll take extended complex plane also right now. Okay, so for extended complex plane, I'm not now. If you're clear with it, I had already taught you in the very first class that point of infinity is also a scenario in the extended complex plane. So you have to admit that z equal to infinity will also be some singularity. Okay, and only one function remains to be analytic at infinity. That is the constant function. Even the entire functions that you so to say, like sine z or cos z, which are analytic in mod z less than infinity, would become non-analytic or will become singular at z equal to infinity. Okay, and I gave you a prescription as to how you should be able to understand what are the nature of the singularities. So for that, you are just supposed to do one thing. You just replace z by 1 over w and see how w equal to 0 behaves in that scenario. Okay, so right now I'm giving you a few questions. What you're supposed to do, you are supposed to find the singularities in the finite complex plane. Also, you are supposed to find what will be the singularity at z equal to infinity. Okay, so let us start with a simple question first. Uh, so what do you think about this particular function? So fz is equal to z raised to power 8 plus z raised to power 4 plus 2 divided by z minus 1 raised to power 3 z 3z plus 2, I think, raised to power 2. We have to find the nature of the singularities. So it's fairly easy to see that z equals to 1 is pole of order 3. So it is a pole of order 3. Z is equals to minus 2 upon 3 is a pole of order 2. I don't think there will be a problem in this. What about z equals to infinity? Now this is something that you have to find. So this I'm giving you around 1 minute. Try to find what sort of singularity is there at z equal to infinity. So what you're supposed to do, you're supposed to replace z by 1 by w. So replace z by 1 over w. What you will get, you'll simply get f1 over w is equals to, I think, 1 over w raised to power 8 plus 1 over w raised to power 4 plus 2 divided by, I think, 1 minus, sorry, 1 by w minus 1 raised to power 3, and I think 3 divided by w plus 2 raised to power 2. And when you solve it all together, you get power 5 from here. So in the denominator, you are left with, I think, power 5. So power 5 will go up. So it will give you 1 over w cube plus w plus 2w raised to power 5, if I'm not wrong. Okay. And divided by 1 minus w raised to power 3, 3 plus 2w raised to power 2. And this w will go all the way around. And this will give you, I think, 2w raised to power 8 plus w raised to power 4 plus 1 divided by w cube 1 minus w raised to power 3, and this will be 3 plus 2w raised to power 2. I hope it is clear. So clearly you
Yes,
can
sir.
see that w equal to 0 w equal to 0 is a pole of order 3 from here. Since w equal to 0 is a pole of order 3, it implies what? It implies z equal to infinity is a pole of order 3. I hope it is clear.
Yes, sir.
Yes, sir.
ओके सो ये तो सिंपल हो गया. ठीक है, अब मुझे बताओ नेक्स्ट केस. Just try to do this question. Let's say if I'm giving you 100, this would be easy. Okay, so if I'm giving you, let's say z square upon, I think z square plus 1 divided by z is to power 3 by 2. Z square plus 1 divided by z is to power 3 by 2. So it is fairly easy to see that it is root z plus z is to power minus 3 by 2. And I've already told you that z equal to 0 is a branch point for these functions. Such type of function, I've already taught you, z is to power p over q is a q valued function. And for a q valued function or for a multi-valued function, z equal to 0 is a branch point. So z equal to 0 is a branch point here, z equal to 0 is a branch point here, so z equal to 0 is a branch point. I don't think there would be any doubt regards this. Okay. And what about z equal to infinity? How would z equal to infinity be? What sort of singularity would be at z equal to infinity? In order to judge that, you have to just replace it by 1 over w. So you'll get 1 over w square plus 1 divided by 1 over w raised to power 3 by 2. You will get w raised to power 3 by 2 divided by w square plus w p power 3 by 2. And you will be left with w raised to power minus 1 by 2 plus w raised to power 3 by 2. Now for w equal to 0, again these two functions are multivalued functions. See, w raised to power 1 by 2, again p by q form. W raised to power 3 by 2, again p by q form. So at w equal to 0, you have a branch point. So since at w equal to 0, you have a branch point, it implies that at z equals to infinity, you have a branch point. Okay, is it clear to you?
Yes, sir.
Okay. Okay, so just do a one question and we'll move ahead with a different topic. Try to do this question. Tell me what sort of singularities are there on the extended complex plane for the function z plus 3 iota raised power 5 divided by, I think, z square minus 2z plus 5 raised to power 2. So what sort of singularities are here in this particular case? एनी आइडियाज? जल्दी जल्दी बताओ बेटा, फिर आगे बढ़े।
सर ये पोल आ रहे हैं 1+2 आयोटा पोल ऑफ ऑर्डर 2
हम्म
एंड 1 - 2 आयोटा पोल ऑफ ऑर्डर 2।
एक मिनट, एक मिनट। सो 1 + - 2 आयोटा क्या रहा है? पोल ऑफ ऑर्डर 2। सो z इज इक्वल टू 1 + - 2 आयोटा आर पोल ऑफ ऑर्डर 2। कोई इश्यूज इसके अंदर?
जी
ठीक है। सिंपली z इक्वल टू अल्फा बीटा इनको बोल दो और सी दैट z माइनस अल्फा इंटू z माइनस बीटा ऐसा लिखा जा सकता है, एंड विल बी एबल टू अंडरस्टैंड व्हाट अबाउट पॉइंट एट इंफिनिटी, व्हाट सॉर्ट ऑफ सिंगुलैरिटी इट वुड बी। सो यू हैव टू फाइंड दैट आल्सो, नो? ये तो ठीक है, एक्सटेंडेड कॉम्प्लेक्स प्लेन में क्या होगा? फाइनाइट कॉम्प्लेक्स प्लेन फाइन है, तो करना क्या है? सिंपली आप क्या करेंगे इसके लिए? I think you will be just doing 1 over w. So this will give you 1 + 3 iota w raised to power 5. Just keep w in your mind. So this will be w raised to power 5 here. And here you will get, I think, 5 w square, I think, minus 2 w plus 1 raised to power 2. And you are left with w square, first square. So w raised to power 4 here. You will get 1 w in the denominator. So w equal to 0 is a simple pole. And if w equal to 0 is a simple pole, that implies z equals to infinity is a simple. Are you getting my point till now?
यस सर।
ओके। अब देखो, फर्स्ट डे मैंने तुम्हें, फर्स्ट डे सेकंड डे मैंने तुम्हें एक इंटरेस्टिंग थ्योरम बताया था कॉम्प्लेक्स एनालिसिस में, दैट इज इफ अ फंक्शन इज एनालिटिक इन अ कॉम्प्लेक्स प्लेन in a region R. So that if I say that a function is analytic in a region R, let's say this is my region somewhere here, this is my region R, and let's say the function is completely analytic in this particular region R, that is your f dash z exists, okay, and this particular function is single valued in this entire region R, then all the higher order derivatives are also analytic. And I told you on the very same date that it gives me a power, or it gives me an authority to write a Taylor series expansion in this region R. Because you might know from your BSc section classes or anyway that a Taylor series is nothing but contains some derivatives, right? So if I'm saying in region R my function is analytic, so I can write a Taylor series expansion about it. So let us move our attention to Taylor series, okay? And this is a very important concept with regards to exam also and otherwise also. So you'll find that most of the times we are doing in physics is some Taylor series. We are truncating it to some terms, saying that these terms, higher order terms, are not that physically good enough to be included, or probably good enough to be included. So most of the times we are doing Taylor series in our physics side. Okay. So what you could do is,
सर ये
हाँ जी, बोलो बोलो।
सर एक क्वेश्चन था सर, ये ऊपर वाले क्वेश्चन में w इक्वल टू 0 सिंपल पोल है, तो उससे
हम्म
हमने z इक्वल टू इन्फिनिटी पे सिंपल पोल है। बट सर यहाँ पे जो कुछ इमेजिनरी रूट्स भी आएंगी, वो सेम आएंगी क्या जो z में आई थी? ये जो दूसरा नीचे
मैं समझ
डिनोमिनेटर में
गया,
फैक्टर है।
मैं समझ गया। देखो होता क्या है, जब तुम z इक्वल टू इन्फिनिटी की बात करते हो, तुम्हें w इक्वल टू 0 ही देखना है, बाकी तो कुछ देखना ही
ओके,
नहीं है। यू आर नॉट
ठीक है
सपोज
सर।
टू सी कि व्हाट इट विल यील्ड यू, ओके? जस्ट सी व्हाट w इक्वल टू 0 इज गोइंग टू यील्ड यू, okay? Because in
ओके सर।
extended number system, 1 over 0 what you will write as infinity, otherwise you will write 1 upon 0 as not defined, okay? But in extended systems you will write this is the notation that we usually use. So therefore you will be able to say that w equal to z equal to infinity would means w equal to 0. So just see w equal to 0, nothing else.
ओके सर।
समझ? ठीक है। अब हम आगे बढ़ रहे हैं, लेट अस सी व्हाट वुड टेलर सीरीज बी। ठीक है, हाउ वुड टेलर सीरीज लुक लाइक? So if I'm saying my function is, so let's say, let me define. So if I say, let's say my function is analytic in region R. So if my function is analytic in region R, और इसको एक काम करते हैं, थोड़ा सा अच्छा बना देते हैं, तो लाइफ थोड़ी सी हो जाएगी। लेट मी से दैट माय फंक्शन इज एनालिटिक एट z नॉट, and let's say there is a region and I should take a circle, so that would be an easy thing for me to do. So if I take a circle, now for every z inside this circle, for every z inside this circle, for every z inside this circle, which is centered at z naught, centered at z naught, I can write my fz in some Taylor series. And what is that Taylor series? Taylor series is nothing but it is an expansion, it is an infinite power series of this sort. So if I'm saying my function is analytic at z naught, that would tell me that there exists some neighborhood of z naught where your function is differentiable. And I told you on the very first day that if in a region R, my first derivative exists, that is, my function is analytic, then all the higher order terms, higher order derivative would exist. So this is the beauty of complex analysis. I'm not going into the derivation part, but I'm just trying to make a point. This is a statement that you should remember. So I can write my function in this particular region R. Let's say this is region R, or let's say circle C, or whatever you want to call. So z minus z naught का double derivative into z minus z naught का whole square divided by 2 factorial plus z minus z cube z naught की power 3 divided by 3 factorial, so on and so forth. So you can write it in this. My bad. Okay. Double derivative. Okay. So this is what it is. So this will be an infinite series of of which would look like this. So this is your Taylor series expansion. So this is your Taylor series expansion for z equal to z. Okay. Now it turns out that how to understand where this particular what would be that particular circle around z naught where you can write your function, or where you can represent your function in this kind of infinite series. That particular circle is called as domain of convergence, or simply circle of convergence. Domain of convergence, or circle of convergence, or region of convergence, or जैसा तुम्हारे को मन हो वैसा कहने का, in any of these ways. Or and this particular region is called as domain of convergence, circle of convergence, or region of convergence, and the radius r is called as radius of convergence. Okay, so all these things are fairly easy. So हमने क्या कहा, what did we say, that if at z equal to z naught my function is analytic, that means there would be some neighborhood, where all your higher order derivatives exist, and you can write this function in a Taylor series expansion. Now question arises as to what would be that dimension of circle about z naught where you can write your function in such kind of infinite series. Okay, so that particular circle is called as your domain of convergence, and that particular radius is called as the radius of convergence. Let us take a very simple example at first. Achha, okay. So how to determine that particular radius? So you must be knowing there are two tests. So I would write test for convergence. So first, so test for convergence. So how to test what is the domain of convergence? So the first test that is very handy is your ratio test. So first test that is very handy in determining is ratio test. So if I say my series is of this sort, summation un. Okay? If summation un is a series, and if I'm supposed to find what is the radius of convergence for this series, what am I supposed to do? I'm just supposed to do this operation and find that what is the limit. Let's say limit is L. If my limit L is less than 1, then my series is convergent. So I'm writing a few things which are of series side, because series is also an important topic in your jam kya bol raha hu, net syllabus, and otherwise also. L greater than 1, series is divergent. And L equals to 1, you will not be able to give any sort of conclusion. So therefore, I'm writing inconclusive. So you're not, if L comes to be equal to 1, you don't know whether your series is convergent, divergent. You would need some other things to make you to make some sort of conclusion regards this. Okay, so let's say if I'm taking an example. So for example, So for example, let us take function fz is equal to e raised to power z. The most standard example, we know this particular function is an entire function. We know this particular function is an entire function. That is, it would converge on the entire finite complex plane. And what is your finite complex plane? This is nothing but mod z less than infinity. This you know. Okay. So first is, let us take example e की power z. So let us first find whether this series is convergent or divergent or what. Okay. Achha, further also note one more formula, that is radius of convergence. So how to find the radius of convergence? You just write one formula and that would be it. So if I'm saying my power series I can expand about z equal to z naught, then I would write that my z minus z naught ka mod is less than r is my domain of convergence. देखो मेरी बात समझने की कोशिश करो. मैं कह रहा हूं कि z equal to z naught के about, if I can expand my function in a Taylor series, so obviously z equal to z naught के about पे एक circle बना सकता हूं. If I can make that circle, I can write this thing also, this radius also. This radius r is called as radius of convergence, and this entire domain is called as the domain of convergence. Okay. And what is the radius of convergence? So radius of convergence is in the form of ratio test, I would say, limit n tends to infinity. I think it is क्या होता है un plus 1 tn plus 1, yeah, un upon un plus 1. Just give me a time. I think this is un plus 1 upon un is 1 over r. ठीक है. Is it right? Beamson ऐसे ही होता ना, इसमें जस्ट उल्टा तो नहीं होता, कंफ्यूजन हो जाता है कभी बच्चों. I hope it is clear.
यस सर ये.
ठीक है, ये होता है. So if your r comes out to be infinity, it implies your function is an entire function. Infinity का मतलब क्या है कि आप किसी पॉइंट पर हो, वहां से आप इन्फिनिट रेडियस का एक सर्कल बना सकते हो, जिस पूरे सर्कल के अंदर आपकी फंक्शन को एक इन्फिनिट सीरीज के फॉर्म में लिखा जा सकता है, फिर टेलर सीरीज के फॉर्म में लिखा जा सकता है. एंड इफ योर r is equal to 0, if r equal to 0, then you cannot draw any circle. Then then you would say that your function is non-analytic. मेरी बात समझ में आई? ऊपर से चली गई. So if I'm saying that your r is equal to infinity, then your function is analytic on the entire domain. On the entire domain means on the entire complex plane. Since it is analytic on the entire finite complex plane, that implies r equal to infinity will come for entire functions. And if r equal to 0, then it is analytic nowhere. Are you getting my point? Yes or no? यहाँ तक समझ में आ रहा है? ऊपर से चला गया.
यस सर.
है ना. चलो अब सबसे पहले लेते हैं एग्जांपल e रेज़ टू पावर z का, और समझते हैं कि e रेज़ टू पावर z का जो फंक्शन है वो उसका डोमेन ऑफ कन्वर्जेंस क्या होता है. e रेज़ टू पावर z याद करो क्या होता था, 1 प्लस z स्क्वायर अपॉन 2 फैक्टोरियल z क्यूब बाय 3 फैक्टोरियल सो ऑन एंड सो फोर्थ. So what I would do, I would simply write it in this fashion. So e raised to power z is nothing but summation n equal to 0 to infinite z raised to power n upon n factorial. Okay. So what would be the radius of convergence? The radius of convergence is limit n tends to infinity. I think un upon un plus 1. So if I write un plus 1 upon un, limit n tends to infinity as 1 over r. So I can write r is equal to un upon un plus 1. So what is un here? So you can clearly see your un is 1 upon n factorial. Yes or no? अच्छा, तो मेरे को un नहीं बताया कि मैंने. So, एक मिनट को. I think this will be a problem for you. Just write it in the fashion positive. Okay. इसको लिखो यहाँ पे an. Otherwise you will get confused. An. And you write un as summation an into z की पावर n. Okay, तो कंफ्यूज हो जाओगे. So un is a series such that it can be written as summation an into z raised to power n. And what is the radius of convergence? Radius of convergence is nothing, but it is equals to an plus 1 upon an limit is equals to 1 over r. So if I write instead of this, अब मुझे बताओ ये e की पावर z जो सीरीज है, क्या मैं इसको ऐसे लिख सकता हूँ an into z की पावर n समेशन n इक्वल टू 0 से लेकर इन्फिनिटी. और यहाँ पे an क्या है बेटा? an is equals to 1 upon n factorial. Yes or no? Since an is equal to 1 upon n factorial, तो यहाँ पे क्या आएगा? an is equal to n factorial, तो हो जाएगा 1 upon n factorial divided by 1 upon n plus 1 factorial. Yes or no? किसी को नहीं समझ पा रहा तो प्लीज पूछ लो. थोड़ा सा एक इशू हो गया था यहाँ पे. So you just correct it. ठीक है? So this is an plus 1 upon an. an is the term which is associated with z की power n. So what will be the radius of convergence? This will come as n plus 1 and limit n plus 1 is infinity. So clearly the radius of convergence for e की power z is infinity. It implies your function is an entire function. समझ में आई मेरी बात? ऊपर से चली गई है फिर. कुछ तो बोलो प्लीज, लेट मी नो.
हाय सर.
बाकी सब काम मर गया.
Got it.
गॉट. अल्पना को समझ में थोड़ा सा वो इशू हो गया था यार, मैंने जल्दीबाजी में. ठीक है, ये रेशियो टेस्ट लिख रहा था मैं. रेशियो टेस्ट का मतलब समझो, अगर समेशन यूएन कोई सीरीज होती है तो यूएन प्लस 1 अपॉन यूएन का मॉड एल के बराबर आना चाहिए अगर एल लेस देन 1 है. अब देखो यही का ये टेस्ट भी यूज करना चाहो तो कर सकते हो. कैसे? अगर तुमसे मैं कहूं कि लिमिट n टेंस टू इन्फिनिटी un प्लस 1 अपॉन un का मतलब क्या होगा? सो इफ आई राइट un प्लस 1 अपॉन un का मॉड का मतलब क्या होगा? इसका मतलब हुआ लिमिट n टेंस टू इन्फिनिटी un प्लस 1 अपॉन un क्या हो जाएगा? an प्लस 1 z की पावर n प्लस 1 डिवाइडेड बाय an z की पावर n का मॉड. अगर ये कन्वर्जेंट है तो ये लेस देन 1 आनी चाहिए लिमिट. इसका मतलब क्या हुआ? an प्लस 1 अभी अभी हमने लिखा, क्या लिखा उसको? an प्लस 1 को अभी अभी हमने लिखा 1 अपॉन n फैक्टोरियल. याद करो 1 अपॉन n प्लस 1 फैक्टोरियल हो जाएगा 1 अपॉन n प्लस 1 फैक्टोरियल. और an ऊपर चला जाएगा तो n फैक्टोरियल. और ये हो जाएगा मॉड ये सब कुछ मिला के ऐसा. और ये अल्टीमेटली क्या होगा? यहाँ से एक कैंसिल, दिस विल गिव 1 अपॉन n प्लस 1, 1 अपॉन n प्लस 1 वहां गया, इट विल गिव यू मॉड z लेस देन इन्फिनिटी. इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि आपका e की पावर z का जो सर्कल ऑफ कन्वर्जेंस है वो है मॉड z लेस देन इन्फिनिटी. मतलब आप ओरिजिन पे जाओ, यहाँ z नॉट की जगह क्या है? ओरिजिन. आप z नॉट पे जाओ, दैट इज योर ओरिजिन. यू मेक एनी सर्कल अराउंड इट, एनी इन्फिनिट सर्कल अराउंड इट, मतलब इन्फिनिट नेबर, infinite radius का circle बनाओ, that is you can cover the entire plane. So it implies e की power z को आप इस फॉर्म में लिख सकते हो. किस फॉर्म में? You can write e की power z in an infinite series for the entire complex plane, for entire finite complex plane, for entire finite complex plane. Are you getting my point? Yes or no? फटाफट से बोलो. So just find me a few radius of convergence
सर ये
and you will.
कन्वर्जेंट होगा.
हाँ बेटा,
This series will be convergent.
this series is convergent. E की power z is convergent series. So this series is a convergent series for the entire complex plane. Implies, तो मुझे, you just give me a point here. I will say okay. I will find e raised to power z here, and I will also find e raised. I will also put that point in your series. Both will converge to the same. Both will converge to the same answer. So this is a convergent series. Okay, so e raised to power z is equal to 1 plus z square by 2 factorial z cube by 3 factorial. It is convergent for all mod z less than infinity. That is, it will be convergent for all for the entire finite complex plane. At z equal to infinity, certainly it is non-convergent because it turns out that we've done that all these things. We've studied singularity at infinity, and we know that only one function remains to be analytic at infinity. That is constant function. इसमें कोई दिक्कत
ओके सर.
है ना? मैं तुम्हें अभी बता रहा हूँ. देयर वाज अ टाइम, आई डोंट नो द, आई शुड नॉट टेक द नेम ऑफ द पर्सन. राइट नाउ ही इज इन स्टैनफोर्ड. ही वाज सो सरप्राइज्ड टू सी, आई एम जस्ट टेलिंग, मैं फिजिक्स वाले बच्चों की बता रहा हूँ. ही वाज सो सरप्राइज्ड टू सी दैट दिस सीरीज इज नॉन कन्वर्जेंट. ही वाज नॉट, he was not able to convince himself that this is non-convergent and this is convergent. So please, जो फिजिक्स वाले बच्चे हैं उनमें क्या होता है, व्हाट दे सी, दे डोंट सी दिस, they don't see this sum, they see 1 over n. I am not saying 1 upon n is not convergent, this is indeed convergent. But if you write the series form of this, so if I am saying 1 plus 1 by 2 plus 1 by 3, this is non-convergent. Okay, and 1 upon n square is convergent. So all these things we'll do today, from today or tomorrow also. But इसको थोड़ा दिमाग में लाओ, बिकॉज ये मैंने देखा है फिजिक्स में बहुत लोग ये चीज सोच नहीं पाते. एंड प्रॉब्ली व्हाई भरत वाज अमेज्ड, बिकॉज प्रॉब्ली ही वुड बी सीइंग दिस, जितनी मेरी समझ कर इसको जेड दिख रहे होंगे ऊपर, एंड उसको साथ में
यस
इन्फिनिटी
करेक्ट
भी दिख रहा होगा, पक्की बात है. ठीक है, और ही वुड बी सेइंग अरे यार ये क्या हो रहा है, व्हाट इज हैपनिंग, ये कैसे हो सकता है. So this happens a lot many times with physics people. तो प्लीज मैं इसलिए थोड़ा थोड़ा सा पढ़ा ही दूंगा तुम, ठीक है. मतलब मैं तुम्हें थोड़ा सा सीरीज वाला पोर्शन भी पढ़ा दूंगा, क्योंकि एग्जाम में आ जाते हैं क्वेश्चन सीरीज पे भी. मतलब वो पता नहीं ऐसे रैंडम कहीं से भी पूछ लेंगे तुमसे. तो और ये भी याद रखना, जैसे तो, और उस लड़के का बैकग्राउंड बता रहा हूँ, कॉस्मोलॉजी में था. ठीक है, and he went to Stanford for doing a PhD and he was so amazed to see these things. And it is so very obvious. तुम अगर रीमन जीटा, चलो वो मैं बात बताऊंगा, पर ये समझने की कोशिश करो, e raised to power z is an entire function because the radius of convergence comes out to be infinity, or otherwise you find the domain of convergence is mod z less than infinity, implies your function is an entire function. So what do you think would be a radius of convergence for these? तो तुम मुझे बताओ radius of convergence for the following series. So find me the radius of convergence for the following series. So radius of convergence is a detailed topic. इस पे क्वेश्चंस आते हैं एग्जाम में भी. So इस पे फोकस रखो, ठीक है. So मुझे कभी कभी बताना पड़ता है कि फोकस रखो, क्योंकि people start thinking कि इनमें से कुछ भी नहीं आएगा, आएगा इसमें से, चिंता मत करो, ठीक है. So question number 1, try to solve me this problem. Let's say z raised to power 2n divided by 4 raised to power n and n raised to power alpha, where alpha is positive and mod z is less than k. Try to find what is the radius of convergence for this series. And this is an important concept in physics also. So if you are given a radius of convergence, in that radius of convergence, you are able to expand your function in some infinite series. Okay. And then there are many theorems in mathematics which suggest that what is uniform convergence or what is absolute convergence. So इतना नहीं डिटेल में जाएंगे हम, लेकिन एटलीस्ट वी शुड बी एबल टू फिगर आउट रेडियस ऑफ कन्वर्जेंस क्या है, and what is the utility of radius of convergence. We'll straight away write the proper points and we'll go ahead. So in order to find the radius of convergence, when I gave you the prescription, all you need to do is you are just supposed to find limit n tends to infinity an plus 1 divided by an mod, and this is equals to 1 over r. But the point is, here you are given z raised to power 2n, not z raised to power n. Okay. So here you are given z raised to power 2n and not z raised to power n. So you are likely to make a mistake here. So that is why I gave you the question. So what you do, instead of using this formula, just use this formula. Limit n tends to infinity, un plus 1 upon un ka mod should be less than 1. Okay. So this will give you a region of convergence. So this will give you what? This will give you a region of convergence. And region of convergence is tarike ka aayega. So whatever is on your right hand side is the radius of convergence. ये भी कर सकते हो, I have no issues, but the only point is you will have to make certain transformation with regards to this. So it's better idea would be to find the region of convergence, and once you find the region of convergence, let's say mod z is less than some r, that r would give you the radius of convergence. Why I'm doing this? Because here you have z raised to power 2n, not z raised to power n. So I have changed the format of the initial thing that I have gave you. Okay, so let us do, this will be the final question, don't worry. इसके बाद हम बंद कर देंगे because I think it's getting too much for you right now. एक बार इसको निकालने की कोशिश करें. Okay, so how would you do? Just find the limit n raised to power infinity and you are left with 4 raised to power, I think un plus 1. So first अपने काम करते हैं, इसको लिखते हैं z raised to power 2n plus 2. n की जगह n plus 1 लिखना है, ठीक है, कंफ्यूज मत होना. n की जगह you have to write n plus 1. So this will come as 4n plus 1, n plus 1 raised to power alpha divided by un. So un will, so here you will have un. So you are left with limit n tends to infinity, z square. So 4 raised to power n will go up. So it will leave you 4 here. And इसके अलावा क्या रह जाएगा, n raised to power alpha upon n plus 1. ऐसा कर दो इसको. A mod should be less than 1. Should be less than 1. और यहां से क्या आएगा, लिमिट n tends to infinity. It will give you mod z, sorry, this is z का स्क्वायर अपॉन 4. और थोड़ा ध्यान से देखो इसको, इस n को देखो, n इसको ऐसा लिख दो, इसको ऐसा लिख सकता हूँ 1 अपॉन 1 प्लस 1 अपॉन n raised to power alpha का mod should be less than 1. n tends to infinity, this will go to 0. So this is 1 raised to power some positive numbers. This entire thing will become 1. This entire thing will become 1. No doubts about this. So ultimately you are left with z square का mod less than 4. And you can write z square का mod लो या mod z का square लो, बात एक ही रहती है. You can easily verify that. So mod z का whole square is less than 4 means mod z is less than 2. It implies your region of convergence is mod z less than 2, and which would give you radius of convergence as 2. So I told you whatever resides here is your radius of convergence. So radius of convergence is 2. Clear? यहाँ तक समझ में आई बात? आंख लगे बच्चे सारे. Are you getting my point? कि बिल्कुल ऊपर से जा रहा है.
हाँ जी.
Yes, sir.
Okay. So एक और क्वेश्चन करो. Just find me the radius of convergence for this series. नहीं, I'll find it for you, but just एक बार देखो. Summation n equal to 0 से लेकर infinite 1 upon n factorial iota z minus 1 divided by 2 plus iota raised power n. How to do this problem? So what you do, थोड़ा सा इसको ध्यान से देखो, इसमें z माइनस z नॉट जैसा कुछ नहीं दे रखा, पहले उस फॉर्मेट में लाने की कोशिश करो. सो दिस विल बी योर n फैक्टोरियल, इसको आगे कर दो, 1 अपॉन 2 प्लस आयोटा की पावर n, इसको आगे कर दो, एंड जस्ट टेक आयोटा कॉमन फ्रॉम हियर. आयोटा कॉमन लेने से आएगा 1 बाय आयोटा इधर की पावर n, एंड इधर आ जाएगा आयोटा रेज टू पावर n, एंड दिस इज योर सम. So your z naught is nothing but it is equals to what? It is equals to minus of iota. थोड़ा ध्यान से देखोगे, इसको ऊपर नीचे मल्टीप्लाई कर दो. So what you will get iota का स्क्वायर नीचे और ऊपर जाएगा iota. This is z plus iota. So तुम किधर एक्सपैंड करो सीरीज को? About minus iota. थोड़ा ध्यान से देखोगे तो you are expanding the series about, देखो ना, इसको ऊपर नीचे मल्टीप्लाई करो iota से, तो this will give you this. So now तुम्हारी पूरी जो सीरीज है वो किस फॉर्मेट में आ गई? उस फॉर्मेट में आ गई जिस फॉर्मेट में तुम्हें चाहिए. पहली चीज तो ये समझो. So you have the series in the format an z minus z naught की power n summation. So this is a power series which is about minus iota, and this is your an. How to find your radius of convergence? You just find this 1 upon r is equals to limit an plus 1 divided by an ka mod. So an plus 1 upon an ka mod, you will get in plus 1 upon 2 plus iota n plus 1, and again 2 plus iota n divided by iota to power n. Just find me this and you'll be able to find the radius of convergence. So this I'm leaving you it as a homework right now. So you just find what will be the answer to this.
Sir, n plus 1 factorial term will also be there. Okay, you have written.
Acha, sorry. So एक term n plus 1 factorial भी है. Sorry. So this will give you n plus 1 factorial here, and here you have n factorial. So this gets cancelled. The answer would be, I think, you just find, I think this would be 0. So that implies radius of convergence is infinity.